Find the unbiased minimum variance unbiased estimator of theta. The Cramer Rao inequality is used to calculate for the minimum unbiased variance estimator of any distribution. Here we have the Bernoulli distribution. For you to get more of this, you need to subscribe to this channel. So how do we find the minimum variance unbiased estimator of the Bernoulli distribution? We will recall that the Cramer Rao inequality states that n differential of the mean function theta all squared. So this is the Cramer Rao inequality. So if we are given this distribution, given theta 1 minus x. So if we are given this distribution, all we need to do first, we'll take the mean function before we differentiate and then compare it with the Cramer Rao inequality. So we take the mean function. That means take the log. If we take the log, it becomes the mean of this, which is equal to x ln theta plus 1 minus x, because this will come over to this place, ln 1 minus theta. The next thing we do is to differentiate. The next thing we do is to differentiate. So we say, take, which is this? Take the differential. So when we take the differential, we go over to this place. It means we'll have something like this. With respect to theta, it gives, if we differentiate this, we get x all over theta. If we differentiate this, we get plus 1 all over x all over 1 minus theta. Since we are differentiating with respect to theta, it will now be multiplied by minus 1. So we will have something like x all over theta minus 1 all over x. Let's put this here, and 1 minus theta. So all we need to do is just to cross multiply. If we cross multiply, we'll get something like this. X times 1 minus theta all over, minus theta multiplied by 1 minus x all over theta 1 minus theta. So if we open the brackets, we have here to be x minus x theta minus theta plus x theta all over theta 1 minus theta. So this will cancel this. We'll be left with x minus theta all over theta 1 minus theta. So this is what we'll be left with. And the whole of this is equal to this. So all we need to do is just to compare what we have with the Cramer Rao inequality. We come over to the side. Just to compare with the Cramer Rao inequality. If we are comparing the Cramer Rao inequality, it means we first write n, which is we have the f of x theta all over the theta all squared to be equal to the expectation of x minus theta all over theta 1 minus theta all squared, which is equal to the expected value of x minus theta all squared all over theta squared 1 minus theta all squared. And we know that this is our variance, is variance of x all over theta squared 1 minus theta all squared. You say, but the variance of x is equal to theta 1 minus theta. That means we can have this as n in f of x all over the theta to be equal to, since variance is this, we have it as theta 1 minus theta all over theta squared 1 minus theta squared. So the whole of this will cancel this to give us 1 all over theta 1 minus theta. So if we now multiply with our n, we'll have n 1 minus theta all over theta, which will give us n all over theta times 1 minus theta. But this is not the final answer because we've not compared it with the Cramer Rao inequality completely. So if we compare it with the Cramer Rao inequality, we have that the Cramer Rao inequality is 1 all over n expected value of the mean function of x in theta all squared will now be equal to, we will now bring this, because of this one that is here, which makes it an inverse, because of that one, as this, our answer is coming over here, it becomes theta 1 minus n all over n. So this becomes our answer. This becomes our answer. So that is how we can compute the unbiased minimum variance unbiased estimator for the Bernoulli distribution.